In this video, I'll set up some code I plan to use in the remaining challenges and lectures. I'll again set this up as an independent challenge if you want to try it on your own. This code will be using generic types and lambda expressions and will be available as a resource in the upcoming video. The game console will be a container to execute some scanner code to drive a text-based game's play. It'll collect a username, creating a player from that. It will start a while loop, displaying a menu of options for a user, then solicit a user's response. It'll execute a game or player method based on a user's selected action and end the game if the action indicates the game is over. This game console class is a container for a game, so it needs a type argument for a game field. It should also have a static scanner field, which uses system.in to get keyboard input. You should implement two methods on this class. The addPlayer method will prompt a user for their name, read in the response from the scanner, and delegate to the game's addPlayer method. The playGame method will display all available game options, soliciting user input in a while loop, and then should call the action associated to the input. The constructor should take a new instance of a game. You'll also want to create a game action record with three fields. There should be a key, a char field, which is the key a user would press to select the action. Next, include a prompt, which is displayed to the user to describe the specific action. There should be an action field for a lambda expression or method reference. I'll be using a predicate with an integer type argument. The integer is the player's index in the player list. A predicate always returns a Boolean result. This will be used to continue or end the play. Next, you'll want to create a player interface. The player interface should have a single abstract method, name, that returns a string. A game's player should implement this type, use this type as a type parameter for game. The game class should be abstract and generic, and the type parameter should be a type of player. This class should have three fields, a game name, a list of players, and a map of game actions. Your game class should have two abstract methods you want any custom game to implement. The method createNewPlayer will return a new instance of the type used for a player. The method getGameActions will return a map that associates a character a user would enter with a prompt and an action to be taken. For example, if a user selects Q, this should map to a game action record that has quit program as the prompt and a lambda expression calling the quit method on the game with a method reference this : quit game. This class should have concrete methods, some of which might be overridden by subclasses. The addPlayer method takes a string for name, creates a player instance, adding it to the game's player list, and returns that index. The executeGameAction will call the predicate's test method on the lambda expression in the action field, returning the Boolean result. The printPlayer and quitGame methods are the methods referenced in the GameAction records. Include getter and helper methods as appropriate. Finally, create your own simple game and player type and test some of the methods on the game console. Here is a model of the types I just explained, which I'll be building. I've created a new project called Game Console, and I have the usual main class and main method. I'm going to start with the player interface in the dev.lpa.game package. I'll include one method, name, that would match a record's accessor method if it had a field called name. I'm going to reference this method in game for any player type. That's all I need for the interface. This type gives me a way to describe all kinds of game players. Next, I'll create the game action record, again in the same game package. I only want three fields, key, prompt, and action. I've said that key should be a char and prompt the player with text contained in a string. Action is going to be a functional interface type. I could have chosen from several different ones, but I chose predicate because I want the game to continue until some condition is met. Any one of these game options could end the game. I'm using integer as the type because that lets me get a player from the players list and execute methods on player as part of a game's method. This will become clearer later as I set up the data. Now I want to build the game class in the same package. I'll make this both abstract and generic. I'll define the type and I'll put that in angle brackets using t as my type parameter, and that needs to extend player. My game will be a container for players if that helps you think about it that way. I'll add my 3 fields. I'll have a game name. I'll set up an array list for players and initialize it here. I want a standard set of actions that every game might have, like quit or info. For now, I'll initialize this to null. The first 2 will be final because I want to use the techniques we've been discussing, making this class as immutable as possible. The third, the key map, will vary by the type of game and user. Now I'll generate a constructor using just the game name. I'll generate a getter for game name and standard actions. I'll create my 2 abstract methods. The first method, create new player, has a return type of just t, and that takes a string name. Next, this method returns a map and the key is a character, and value is a game action. The name I'll use is getGameActions, and it will take a player index. This means game actions could be unique for each player. Any subclasses extending this class have to write their own custom implementations of these methods. Next, I'll focus on the getStandardActions method that I generated earlier. I'll insert an if statement before the return statement. This will check if the standard actions map is null first. If it is, it will populate it with 2 standard actions, I for information, and that will call a printPlayer method on the game, and Q to quit, which will call quitGame on the game. I'll make this a linked hash map, so instructions get printed in insertion order. I'll use map.of, which lets me pass a series of keys and values in order. It takes first a key, then value, then the next key, and the next value, and so on. The first key is I. This will be a key to the map, as well as a field on the game action record. The prompt for this will be printPlayerInfo, and the method will be printPlayer called on the current game instance. I'll use a regular lambda expression here, so you can see the parameter is an integer, and I'll call the printPlayer method on this class that takes an integer and returns a boolean. Next, I'll have Q to quit the game. The prompt is quitGame, and the method it will call is quitGame. The lambdas I'm using here won't compile until I include those methods on this class. I'll do that shortly. First, I'll add the addPlayer method that takes a name and returns an integer, the player index. I don't want subclasses to have their own versions, so I'll make it final. I want my game console to have access to it, so I'll make it package private, meaning no access modifier. I'll first call the abstract method createNewPlayer and assign that to a t-type local variable. Each subclass will have to implement the createNewPlayer method, producing the right type of player for the game. If this isn't null, I'll add it to the players list. To return the player's index, I'll get the last index. If we were multi-threading, this wouldn't be a safe way to get a player's index. Otherwise, I'll return -1. Next, I want a method to get a player by the player index. This method will be protected so subclasses can use it, but final so they can't override it. I'll return the player from the players list for that index. Continuing on, I'll add the executeGameAction method, making it public but not final because subclasses may want additional functionality. This will be executing lambda expressions or method references that return a boolean and take an integer. I will have this method do the same, but I'll also include a game action parameter. I'll return the result of the predicate lambda in the action record. A predicates method is test, and it takes the type we declared, so an integer, but I can pass an int because of autoboxing. Finally, I want to implement the 2 methods in my game action record. First, the printPlayer method, which has to match the boolean predicate, returning a boolean and taking an integer. I will get the player from the private players list using player index. I'll print the player string and just return false. Requesting info should probably never end the game. Next, I need the quitGame method with the same return type and integer parameter. Again, I'll get the player by player index. I'll print sorry to see you go using the player's name. I'll return true every time because this should end the game. Okay, that's everything except the game console class itself. I'm going to end the video here and work on the game console in the next video and then put it to work with a simple game. See you in the next video.